Hello everyone, welcome to the Information Theory and Coding class. So in the yesterday's classes, we discussed about the average information contained, that is the entropy of the source symbol in a long independent sequence, and which is given by the expression h of s is equal to summation I is equal to 1 to q pi into log 1 divided by pi bits per symbol. And we also arrived an expression for the information rate, that is nothing but capital Rs is equal to small rs into h of s, which is represented in terms of bits per second. And please don't confuse in this. The entropy we are going to represent in terms of bits per symbol, because since we want to find out the average amount of information conveyed by a particular symbol over the L symbols, whereas this information rate is nothing but with which speed the symbols are produced from the source alphabet. So therefore, the information rate we are going to represent in terms of RFS will be in the form of bits per second. So let us try to solve some of the problems which is associated with the average information rate, or also based upon the entropy of the given signal. So let us consider this example. A discrete source emits one of 6 symbols once every m seconds. So a discrete source we have, it emits 6 symbols once in every m second. So the symbol probabilities they have given 1 by 2, 1 by 4, 1 by 8, 1 by 16, 1 by 32, 1 by 32 respectively. So we have a 6 symbols and 6 symbols probability they have given you. Find the source entropy and the information rate they have given you. Okay, so now let us try to find out. So what are the things they have given you, and what is the things we need to identify, or what is the thing we need to calculate? Let us try to look into it. So we need to calculate the entropy of the given entropy of the given source, and we need to find out the information rate of the source. So we know that the entropy of the given source, which is nothing but h of s is equal to 1 divided by I 1 to q. So in the given problem, they have said that it is 6 symbols. So the I values will take from 1 to 6, pi into log of 1 divided by pi bits per symbols you will be getting. And the information rates rs into h of s bits per second you will be getting. Since rs they said it is m seconds, so the small rs we can treat it as m seconds. So let us try to first calculate the entropy of the source. So the entropy of the source, which will be given by h of s is equal to summation I is equal to 1 to 6 pi log 1 divided by pi. So if I substitute all the summation values over here, so what we'll be getting is h of s is equal to 1 by 2 log of 1 by 2 means you'll be getting log 2 plus 1 by 4 log 4 plus 1 by 8 log 8 plus 1 by 16 log 16 plus 2 symbols we have. So therefore 2 into 1 by 32 log 32 will be getting. So if you do that, you'll be getting entropy of the given source symbol, which is nothing but 1.9375 bits per symbol. And since they said that the information rate we need to calculate, so which is nothing but rs into small rs. So what is that? They said that 4 symbols will be emitted in every m seconds. So therefore 1 symbol divided by m seconds, which will be milliseconds they have said it. So therefore it is rs will be 10 to the power of 3 symbols per second. So if I substitute this rs value, you'll be getting capital Rs, that is the average information rate, which is nothing but 10 to the power of 3 into 1.9375. If you substitute and if you do the multiplication, your average information rate will be getting as 1937.5 bits per second. So now let us try to understand one more problem. So how we can calculate the self information and the average information of the given signal. So let us try to work on this problem. So what we have, a card is drawn from the deck, means you have a deck of cards. So totally in the deck of card we have a 32 cards, 52 cards will be there. Okay. So and these are the some of the information what they have given, and based upon this information they will ask us to calculate some information. Okay. So the first one, you are told it is a spade. How much information did you receive? So you are going to take one card and it is told that it is a spade. So what is the information you are going to get from this information? You need to find it out. Second one, how much information did you receive? If you told that the card drawn is an ace. So there will be ace card in the deck of card, and they told that the whatever the card you have taken, it is ace card means, then what is the amount of information you get from this message you need to calculate. And the third one, if you are told that the card drawn is an ace of spade, so they say that it is ace, but it is of type spade. So how much information did you receive? That you need to calculate. And finally, is the information obtained in the third case and is the sum of information obtained in the first and second case they are asking you. So this you need to find out, and you need to figure it out whether the self information is the sum of information about the case 1 and 2 you need to identify. So in order to solve this problem, first you need to understand, so how many cards will be there in the deck. So as I said you, there will be 52 cards will be there in the deck, and each deck will be having a 4 types of cards. So what are the 4 types of cards will be having? So you will be having a spade, you will be having heart, and you will be having a clover, and you will be having a diamond shape. And each spade will be having totally 13 cards. Each spade will be having a totally 13 cards, and even heart is also having 13 cards. Clover will also having a 13 card, and diamond is also having a 13 cards. So what are the cards it will having? So it will start with the number 2, 3, 4, 5, 6, 10, and you'll be having a ace, J, K, and Q will be having. So when you sum up these, you'll be getting a 13 card. Okay, so based on this information, we need to calculate the first one. So what is that? You have told that it is a spade. So how much information did you receive? Okay, so probability of getting a spade, first you need to calculate. So if you calculate the probability of getting a spade card means, then you can able to calculate the self information of this message. Okay, so you can see here, since there are 13 spade cards, so just now we have told, right? So it is a 13 spade card we have. Among how many cards we have? 52 cards we have. So therefore, the probability of getting a spade card is 13 divided by 52. If I do that, you'll be getting 1 by 4. Means the probability of getting a spade card is 1 by 4. So therefore, self information is nothing but log of 1 by divided by p spade. If I substitute that, you'll be getting 2 bits of information you'll be getting. Okay. So the second one. So what is the second one? They have told how much information did you receive if you are told that the card drawn is an ace. Okay. So now let us try to see how many cards we have, the ace cards we have in the given 52 cards. So you can see here, ace we have in spade, ace we have in heart, ace we have in clover, and ace we have in a diamond. Okay, so there are 4 ace cards are there among a 52 cards. So therefore, the probability of getting an ace card is 4 by 32. So if you do that, sorry, it is 52. If you do that, so what you'll be getting is, so you'll be getting 1 by 13. So therefore, the self information will be given as 1 by the probability of getting an ace card. So if you do that, you'll be getting 3.7 bits. Now, what is the third case they have given is, if you are told that the card drawn is an ace of spade, how much information did you receive? And they already said that it is the ace of spade. So means what? In this a card, so how many ace of spades you have? There is only one ace card is there. How many spade you have? 13 cards are there. So therefore, what you are supposed to do is, the ace of spade, the probability of getting an ace of spade, it is nothing but 1 divided by 52. So if you do that, so you'll be getting 1 divided by 52, you'll be getting 5.7 bits. Okay, so means what? You have told that ace of spade, ace we have 4, but among this, the ace of spade is only 1. So how many total cards are? 52 cards are there. So therefore, 1 by 52, you'll be getting the self information is nothing but log of 1 by probability value. If I do that, so we'll be getting 5.7 bits. Now, the fourth one, read. So what is that? Is the information obtained in the third case is the sum of information obtained in the first and second case, or we need to check it out. So what we do is, we need to add the first output value, that is the first statement value, second statement value. We need to compare whether it is equal to the third statement value. We need to compare it. So the probability of getting an ace is 2 bits, probability of getting an spade is 3.7. So if I add these two, so therefore LHS is equal to RHS. So we can say that the self information obtained, it is the sum of self information of the individual messages. We can say that. Okay, so this is how we can solve the problem. Okay, so let us try to go for one more important problem which will be asked in the examination, is that you try to look it over here. A binary source is emitting an independent sequences with zeros and one with a probability value p and 1 minus p respectively. Plot the entropy of the source versus p and comment on the result. So this is the one of the important example or important problem which will be subsequently asked in the examination. Okay, so let us try to find out the entropy of the binary source. H of s is nothing but summation 1 divided by how many sources we have, symbols we have, 2 symbols we have. So I is equal to 1 to 2 pi log of 1 divided by pi. So if I substitute this, what will be getting? P1 log divided by 1 by P1 plus P2 log divided by 1 by P2. But what is the probability of the first symbol? They said it is P. And what is the probability of getting the second symbol? They said it as 1 minus P. So therefore, if I substitute that, so this is the entropy what I will be getting. So since they have not specified any the specific values, so what we should do is we substitute some arbitrary values for this and p for 1 minus p, and let us try to plot, or let us try to find out the value of h of s. Okay, and we know that the probability value which will takes in the value 0 to 1. So therefore, let us try to find out some arbitrary value between 0 and 1, and what will be your h of s will be taken. Let us try to understand. So if I substitute first case p is equal to 0.1, and the second probability value will be 1 minus p, which will be 0.9. So if I substitute that, we'll be getting h of s is equal to 0.469 bits per second. Similarly, if I go for p is equal to 0.2 and 1 minus p will be 0.8. So therefore, h of s will be 0.725 bits per second. Similarly, p3 will be 0.88 bits per symbol. P4 will be 0.97 bits per symbol. P5 will be, if it is 0.05, then h of s will be 1 bits per symbol. So if I plot this in the form of tabular column with the probability values with h of s, I will be getting when p is equal to 0, h of s will be 0, p is 0.1, it is 0.46, when p is 0.2, it is 0.72, when p is 0.5, it is 1, and when p is 0.6, it is 0.972, and p is 1, it is 0. So I need to plot out, that is a function of h of s with respect to p. So if I plot this, so this is the graph what you will be getting. Initially the probability will be increases, and as the probability increases, again the value h of s is increasing. Now let us try to understand in which point you are getting the maximum value. Let us try to understand in which point we are getting the maximum value. So you can see here we have a two symbols. What is the probability value? So at probability value, that is 0.5. At the probability value 0.5, that is nothing but when p is equal to 1 by 2 and p1 and 1 minus p is 1 by 2, when 1 minus p is 1 by 2, you are getting the maximum value. So let us try to understand, or let us please make a note of this. This will be used in the properties in the subsequent chapters. Okay, so now let us see what are the properties of the entropies are there. So the first property is the entropy function is a continuous for every independent variables. Means the probability, as the probability values will changes of a particular source symbols, definitely the entropy will also changes. It depends upon the probability value with which the source is emitting. Okay, so that is why it is called as the entropy function is a continuous for every independent values. Now the entropy function is symmetrical function. Okay, so means what? If you have a two symbols means, so if the probability of one event, if it is more means, then the probability of the other event will be 0, means it will be reducing. So if we calculate the entropy in this manner also, or if we calculate the entropy in this manner also, both will be holding the same value. So therefore the entropy of the source symbol will always be symmetrical with its argument value for all the value of the symbol. So the third case is very important. It is also called as an extremal property. What do you mean by extremal property? The entropy attains a maximum value when all the source symbols becomes equiprobable. We try to read out this statement property once again. Extremal property. What is this? Entropy attains a maximum value when all the source symbols becomes equiprobable. That is h of s, you will be getting a maximum entropy when all the source symbols will have a equal probability. Okay, so in the earlier classes we said that we have a q symbols. So if the probability, if it is equal to q symbols, if the probability is equal to 1 by q symbols means, then you will be getting the maximum entropy. Now let us go back to the previous problem what we have done. So how many symbols we had? We have a two symbols, and if I said if the probability is equiprobable means you have a one probability, that is 1 by 1 by 2, and one more symbols you have a p2, that is nothing but 1 by 2, 1 by 2 you had. So you can see what is the number of symbols you have a 2. So the maximum symbols what you have is 2. So you can see when p is equal to 0.1 by 2, you got a maximum entropy. We have a maximum entropy. So means what? When all the symbols occurs with the equal probability, you will be getting the maximum entropy from the source alphabet. So this is one of the important property which we are going to use in solving so many problems. Okay. So the next one we call it as an additive property. So if you partition the given source symbols, then the entropy can be not decreases. Obviously it will be increases only. Okay. So therefore h dash of s will be h of s plus a positive value. So this quantity will depends upon how you divided your source symbols into smaller blocks. The next one we are going to calculate the efficiency and redundancy of the source element. Okay. So the efficiency is calculated as it is the ratio of entropy of the source to the maximum entropy of the source we will be calculating. which is written as eta S we will be representing, that is the entropy of the source, efficiency of the source, which is calculated as H of S divided by the maximum entropy of the source. If you divide it, you will be getting the efficiency of the source. And similarly, the source redundancy is nothing but 1 minus efficiency. So this source redundancy will be represented in terms of Rn of S is nothing but 1 by eta S. And generally, we are going to represent this source efficiency and source redundancy in terms of percentage only. Okay, so the remaining things we will look into the next section. Thank you.